Imagine living in a world where you don't need to own a robot to benefit from its services, just as you don't need a car to get around or a home library to read. This could soon become possible with the Tesla Optimus, which will be accessible through a shared-use system. This concept, increasingly popular in the United States, places Optimus at the center of a technological revolution that promises to transform our everyday relationship with automation. Before we continue, we ask for your support. Subscribe to the channel and help us reach our goal of 10,000 subscribers. Your support is essential for us to continue bringing you incredible content about Tesla Optimus and technological innovations. Returning to the main point, the proposal for so-called public robots follows the same logic of the collaborative economy, as does platforms like Uber or Airbnb. Instead of spending a fortune buying a Tesla Optimus, users will be able to hire one on a subscription or hourly basis, democratizing access to cutting-edge technology without the need for a large initial investment. This approach has already shown promising results in other sectors. A study by the University of Oxford, released in 2023, found that services like Uber and Airbnb reduce the need for individual ownership in large urban centers by up to 30%. The same could happen with robots. Think, for example, of a family renting an Optimus for a few hours to help with cleaning, or a restaurant hiring a robot to work during peak hours. Besides eliminating high initial costs, estimated at around $20,000 per unit, this model also cuts maintenance costs. In a scenario where automation is already reshaping entire sectors of the American economy, Optimus finds fertile ground for expansion. According to Statista projections, the U.S. robotics market is expected to grow from $14.8 billion in 2024 to $37.2 billion by 2030, with an average annual growth rate of 16.7%. Thanks to its versatility, Tesla's robot can be adapted to different environments, from homes to industrial production lines. This strategically positions it to operate in areas such as hospitality, healthcare, retail, and others. A good example comes from Singapore, where Changi Airport has been using cleaning robots since 2018. According to internal data, the technology reduced cleaning time by 20% and increased user satisfaction by 15% by 2024. In the United States, Optimus could perform similar functions, operating in busy restaurants or even guiding passengers at airports. In the healthcare sector, the robot could be a valuable ally in the face of an aging population. WHO estimates indicate that by 2050, more than 2.1 billion people will be over 65 worldwide. In the US, the elderly population is expected to exceed 95 million. In these circumstances, Optimus could work in nursing homes, assisting with mobility, reminding patients to take medication, and providing companionship, essential to combating loneliness, which affects 1 in 4 older Americans. In domestic life, shared robot use also tends to generate concrete benefits. According to a 2023 survey, Americans spend on average 6 hours per week on household chores. By renting Optimus for about $10 per hour, similar to cleaning services, people could save time and invest it in leisure, family, or work. A single mother in Chicago, for example, could hire the robot to clean her apartment and thus spend more quality time with her children. The emergence of Tesla Optimus, a humanoid robot designed to perform tasks with human-like precision, marks a new chapter in the advancement of automation. The proposal to make it accessible through a shared-use model could profoundly transform the way we live, work, and interact. Unlike traditional robots, which require large individual investments, Optimus will be usable on demand, like public transportation for the digital age. This new format brings several benefits. It increases efficiency, reduces costs, and expands access to technology more equitably. Thus, Tesla Optimus, seen as a public resource, has the potential to positively influence daily life in the United States, making automation accessible to everyone. But what, after all, are the main benefits that Optimus can provide to society? One of the most significant is increased productivity across a variety of sectors. Unlike human workers, robots can operate continuously, 24 hours a day, without breaks or fatigue. This capability makes all the difference in dynamic environments such as restaurants, distribution centers, and stores. According to McKinsey, automation could increase productivity in the service sector by up to 30% by 2030. Imagine a busy New York restaurant. Optimus could clear plates, serve meals, and replenish stocks without missing a beat. The efficiency of this type of operation is already unprecedented. Singapore's Changi Airport has managed to reduce cleaning time by 20% since adopting robots. In the US, the use of Optimus in places like shopping malls, stations, and public spaces can also generate significant improvements, creating cleaner, more organized environments. In the logistics sector, which employs approximately 2 million people in the United States, Optimus can help with inventory management and order fulfillment, helping to address the labor shortage that causes annual losses of up to $1.3 trillion. Looking to the future, robots like Optimus could become an essential part of everyday life. It's possible to imagine this robot assisting in surgeries, acting as a tutor in schools, or even assisting rescue teams in emergency situations. Estimates indicate that artificial intelligence and robotics are expected to generate approximately $15.7 trillion for the global economy by 2030, with $3.7 trillion in the US alone. In these large metropolises, where the cost of living is high, the impact of automation will be even more noticeable. Beyond all this, Optimus can also play an important role in environmental causes. It could contribute to selective waste collection, reforestation programs, and other sustainable initiatives. According to the UN, automated waste management could reduce inappropriate waste disposal in cities by up to 15% by 2030. Seattle, for example, aims to be a zero-waste city by 2040, and robots like Optimus can accelerate this process. The social impact is also significant. Imagine community centers in rural areas using robots to offer coding classes or telemedicine services. This would be a crucial step forward for the approximately 19% of Americans who still lack access to high-speed internet. These initiatives could boost digital inclusion, education, and local economic growth. However, the spread of public robots faces some obstacles. One of the main ones is the fear of job displacement. According to the World Economic Forum, by 2025, approximately 85 million jobs worldwide could be automated, especially in sectors such as retail and food. In the US, more than 15 million people work in this segment, making the impact especially significant. To mitigate the negative effects, investing in professional retraining will be essential, as Germany did, reducing unemployment by 40% by offering technical training adapted to the new market. Another sensitive issue is privacy. Robots equipped with cameras and sensors can capture personal data in homes or public spaces. Although Tesla promises to adhere to strict data protection standards, distrust remains, especially after information leaks involving large companies. A recent survey revealed that 67% of Americans are concerned about data misuse by AI systems, reinforcing the need for stronger regulations. Furthermore, specific legislation regarding the use of shared robots is still lacking. Who will be held responsible in the event of failures? How can we ensure sanitation between uses? Current guidelines for autonomous vehicles are a starting point, but robots like Optimus require their own regulations to ensure safety and legal liability. Finally, the third-generation Optimus promises to surpass human limits in a variety of tasks. With advanced algorithms and artificial intelligence, it can operate with precision and consistency, reducing repetitive errors by up to 98%, according to a 2023 study. Its neural system, powered by large volumes of data, similar to the one Tesla uses in its self-driving cars, which have already exceeded 1 billion miles traveled, allows the robot to learn by observation. As Elon Musk stated in a 2024 interview, this ability to learn by watching videos makes Optimus ideal for use in environments such as factories, hospitals, and homes. In addition to increasing efficiency, this can also help reduce workplace accidents, which totaled 2.6 million in the US in 2023, according to OSHA. The Tesla Optimus Gen 3 represents an extraordinary leap in the evolution of robotics. More than efficiency and performance, the project was conceived to offer exceptional durability and a clear focus on sustainability. While most commercial robots typically have an estimated lifespan of between 5 and 10 years, Tesla set a bold goal: to make Optimus operate reliably for up to 24 years in real-world conditions with minimal maintenance over time. This impressive longevity is the result of meticulous engineering, from its physical structure to its electronic systems and artificial intelligence software, reflecting Elon Musk's vision of a durable and reliable companion robot for decades. The secret to this durability begins with the robot's skeleton. Optimus's chassis is manufactured from 7275 T6 aluminum alloy, widely used in the aerospace industry for its high performance-to-weight ratio. With a tensile strength of around 83,000 pounds per square inch, this structure is capable of withstanding years of movement, heavy lifting, and precision tasks without compromising its integrity. For the most demanding joints, such as the shoulders, knees, and spine, Tesla opted for carbon fiber reinforced polymer, a lightweight, impact-resistant material ideal for preserving the robot's agility and energy efficiency. Studies released in 2024 by the Materials Research Society confirm that these composite fibers can withstand repetitive stress cycles for up to 30 years, with minimal degradation, furthering Tesla's longevity goal. Inside, the mechanical systems are also designed to withstand the test of time. Each robot joint undergoes tests that simulate up to 1.5 million flex cycles, equivalent to more than 2 decades of continuous use in domestic, commercial, or industrial environments. According to a Tesla publication in 2025, the gearboxes use high-performance synthetic lubricants and stainless steel bearings to minimize friction, while the motors are protected by heat shields and intelligent load distribution systems, preventing overheating. This architecture directly benefits from Tesla's expertise in electric vehicles, whose motors have already surpassed the 1 million mile mark, as highlighted in the company's 2024 reliability report. Optimus's power comes from a battery based on 4680 cells, specially designed to withstand the test of time. Laboratory tests indicate that these batteries maintain 80% of their original capacity after approximately 3,500 complete charge and discharge cycles. In a daily, 6-day-a-week usage scenario, this translates to over 20 years of continuous operation, a figure that can reach 24 years when partial recharges are prioritized. Tesla implemented an intelligent battery management system that adjusts temperature and prevents extreme conditions, such as deep discharges, prolonging battery health. Research published in 2023 in the Journal of Power Sources showed that strategies of this type can increase the lifespan of lithium-ion batteries by up to 25% when compared to conventional methods. A notable differentiator of Optimus is its autonomous intelligence, based on the same advanced AI technology that powers Tesla's autonomous driving system, which has already processed over 1 billion miles of data by 2024. Using neural networks, the robot monitors the wear and tear on its components in real time, identifying joint overloads and adapting its movements to avoid damage. For example, if an arm is being overworked, it can redistribute the task to another limb, preventing long-term structural failure. This self-preservation system, combined with thermal and motion control, maintains stable performance even over extended journeys. Optimus's modular design also contributes to its durability. Components such as sensors, motors, and actuators can be replaced individually without the need to disassemble the entire system. A study published in 2024 by Robotics Business Review revealed that modular architectures can reduce maintenance costs by up to 40% and extend robot life by 50%. To ensure its robustness, Tesla conducts a series of extreme tests on Optimus, including temperature variations between 25 degrees C and 50 degrees C, drop simulations, intense vibration, and dust exposure.